So just to remind you from last time, the structure that we're talking about mostly in this course are graphs, also sometimes called networks, which is a structure, discrete structure consisting of a set of nodes, sometimes called vertices, and edges, sometimes called links. And interestingly, usually the people who call the nodes nodes call the edges links, and the people who call the nodes vertices call the edges edges, because these both come from geometry. But for whatever reason, I mixed them together. I apologize. I tried to change, but it just didn't work. Here's an example of a graph that has 6 nodes, the blue circles here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges connecting those nodes together. In these kinds of graphs, the edges just link up 2 of the nodes, not more than 2, not fewer than 2. And what we're going to be talking about, the edges don't have any direction to them. They just link them together. The particular positioning of them on the page is really irrelevant. What matters is which nodes are connected to which other nodes. So what we're going to be talking about for the next little while are special networks that have particular structures and that usually fall into different families. So one particular family of networks is called the chain networks. Chain networks consist of a set of nodes and a sequence of edges between them that basically connect them into a single chain. So this is an example of a chain network with 5 nodes, 1, 2, 3, 4, 5, and 4 edges, 1, 2, 3, 4, connecting them together. And there's essentially only one such network, right? We can imagine flipping it around or relabeling the nodes, but topologically, there really is only one way of connecting 5 nodes into a chain. Now, I mentioned that this is part of a family of networks, and you get a different chain network for each different possible number of nodes. So now a question that I'd like to have you answer is, how many edges do you have in a network that has n nodes if it's a chain network?